Hello everyone, my name is Rama Karamsetti. I'm going to talk about the path to Industry 4.0, IoT and smart manufacturing along with Mike here from Advantech. I'm a segment marketing manager within the Industrial and Energy Solutions division at the IoT group in Intel. Mike's the director of product management in Advantech. Together, we're going to discuss how is it that we're going to have this path to Industry 4.0. In today's webinar, I'm going to discuss on the trends in industrial automation and energy. I'm going to discuss on the tenets of IoT solutions, a little bit of smart manufacturing, and then Mike's going to take over and go a little deeper into what Industry 4.0 means and what it means to the market trend. And he would also go over a use case as to how we can achieve Industry 4.0 and encourage to examine your company's strategy towards this path. So what's Internet of Things? So Internet of Things is nothing but connecting all the things that are connecting to the Internet, integrating greater compute capabilities, and using data analytics to extract meaningful information. I see that there's a little blank on the slide here on the left portion. What's missing in the picture here is a mobile phone that shows connectivity to the devices on the left or the things on the left through a mobile phone. Apologize for that, folks on the bridge. But overall, let's just see what I'm trying to talk to here. Okay, let's look at some market data. Some of you might have already seen this data. There's 50 billion connected devices, 44 zettabytes of data that's going to be available by 2025. Okay, but what you may not know is that 85% of these devices deployed today, which means around 15 billion, are not connected, presenting not only a huge opportunity over the horizon of the next 5 years, but it also provides us opportunities to deploy new intelligent devices. To add to this, the cost of sensors is going down by 2x, the cost of computing is going down by 60x, and the cost of bandwidth is going by 40x. In combination, all of this creates an opportunity for an inflection point to connect the unconnected, proliferate computing from devices to the cloud, and across cost-effective networks. So all in all, these trends will unleash the IoT opportunity, impacting the way we work and the way we live. And this impact is going to be really huge in the industrial sector. And I'm going to go over why it is so in the next slide. So let's just begin by looking at the key trends in industrial and automation energy. Okay. Some of you are aware of this information, but just want to highlight the key trends that are happening in the market and what is it that makes our business very exciting. Worldwide consumption is doubling in the next decade. It drives the need for efficiency in operations and processes. Manufacturing productivity is increasing, but it needs to accelerate. Since the recession and global financial crisis, productivity has definitely increased. However, in order to keep up with the demand, it needs to double in the next decade. And how do we double in the next decade in productivity? Obviously, technology is going to help. To add to this, the rising labor costs and technology improvements is revolutionizing robotics. The cheap labor geos are a thing of the past, and we are at an inflection point where technology, automation, or robotics provides a better ROI than introducing more labor force. So this is purely because the cost of technology is coming down, and we believe this is going to be a very interesting space over the next few years. The next key trend is functional safety. So functional safety is a little different from security that we always talk about. It mandates driving requirement into new industrial products. These are the methods used to improve the safety of humans on the factory floor from the plethora of new applications, machines, and robotics. The next key trend is the convergence of M2M, big data, and analytics. And all these are causing cyber-physical systems to talk to each other, all leading to new opportunities on the factory floor. The last trend we see in the market for industrial automation and energy are geopolitical investments. What does this really mean, right? It just means that all the countries out there are making sure they're competitive enough, and they're in a way increasing the refresh rates in a traditionally slow industry sector. When in the past you would see that the factory floor on the equipment or the assets and machinery on the factory floor would be refreshed once every 3 to 5 or 7 years even, investments in one part of the world are forcing the other parts of the world to look carefully into their existing manufacturing processes and provide either subsidies or incentives for their own country's processes to improve. So in this process, what triggered all of this, right? All of us might have heard of Industry 4.0, which is predominantly a German and European initiative. So now there are similar initiatives in the US and China with intent to regain competitive advantage in manufacturing in the new industrial revolution. So what is this new industrial revolution? A little bit in detail, and how is it that it was in the past is going to be discussed by Mike in a few slides from now. This is all good for the industry, for us especially, because it helps with accelerating the technology adoption by the slow-moving end customers in the past. So that said, we see these 6 trends, but how does it fare, or how does it look when we look at the total dollar value of these trends? I'm going to go over that in the next slide. Once again, some of you might have already seen this data, but what really excites us at Intel or our partners like Advantech are the opportunities that everyone points to in IoT applications, especially in the industrial and energy sector. Manufacturing, energy, infrastructure, security represent over 55% of the $3 to $6 trillion per year economic impact of IoT applications. So there's a lots of low-hanging fruit in these industries to increase efficiencies in factories, electric grid, oil and gas, or by just connecting devices and analyzing data to run the operation more efficiently. So this means 1.2 to 3.1 trillion of this 3 to 6 trillion yearly impact is going to come purely from manufacturing, smart grid, infrastructure, and security. And a big chunk, or 80 or 90% of it, is from manufacturing and energy industries. So Intel, along with partners like Advantech, is working towards creating solutions that can capture this economic impact. So one key area we are focusing on is smart manufacturing. So what is smart manufacturing, or what does it really mean? Once again, I'm going to go over at a very high level, and then Mike's going to go in detail and go use a use case to explain what smart manufacturing really means. Sorry, folks, it looks like this slide's appearing to be blank too, but what I show in the picture here is, all right, I think it's got fixed now. All right, so what is smart manufacturing, right? So there are many ways in which Industry 4.0 can help benefit. It can optimize delivery of materials from supply chain or provide consistent quality of products to customers. Okay, and it can also improve efficiencies on the manufacturing floor, either through predictive maintenance or increasing the reducing the maintenance time cycles or increasing the uptime. It could help by remote monitoring of critical infrastructures and providing intelligent data. So before we go there, so how is it improving the supply chain? So timely, just-in-time delivery of raw materials can be made possible by smart manufacturing processes. Streamlined logistics from order to raw materials is also possible. So by doing this, we're creating value to the customers at the end. They receive consistent quality of products with very few issues. There's an ability to have responsive customizations of the order. We could also provide timely delivery of alerts and updates to the end customers. Okay, so what's making all of this possible, right? Technologies are available now to make industrial automation intelligent, predictive, and self-correcting. With the explosion of connected devices, accessibility of sensors is enabling massive data generation. And the compute economics we talked about, the reduction in the cost overall, is enabling rich analytics. These are all leading to many opportunities to make industrial automation even more optimized than what it is today. So these are leading to ways in which you could integrate your OT and IT on the factory floor. Now we can learn to turn data into actionable information and in some cases even monetize it. With proper framework, managing devices and normalizing data to ease deployment and interoperability can be easily achieved today. Finally, like I said, turning data into actionable insight requires a broad analytics infrastructure too that spans from edge to the cloud. So this is creating a lot of opportunity for new technology and new use cases and applications for Intel as well as all of our partners. So let me just go over a small example of what it could mean when we say smart manufacturing. So let's say within a factory floor itself, let's look at using predictive maintenance and how it helps maintaining uptime. So a factory can instrument its tools and connect them to the factory floor data center. We can now perform analytics functions on, say, for example, vibration, temperature, pressure, or other sensor data, and be able to predict when maintenance is needed. This helps reduction in spare costs. It also lowers maintenance costs by reducing the preventative maintenance that takes at some preventative maintenance. So basically, up until now, without this information, you probably had a scheduled preventative maintenance cycle. So maybe now you might not need to go by the schedule. You could probably just say, based on the data, that you could either wait a month or wait until you have your own factory downtime in production to actually do your maintenance. So this reduces downtime in an equipment by avoiding unnecessary, unwanted close down or slow down of the process on the factory floor. So in summary, accelerating edge to cloud can help all stakeholders in the value chain. Many areas can be instrumented. Interruption of service is definitely not acceptable, and in the process we can, by going the Industry 4.0 path, we can reduce these interruptions. So being able to extract intelligence in the infrastructure requires a straightforward installation and should be easily bolted onto existing infrastructure. Definitely a must in this case. Okay, so for us to go on this path to Industry 4.0 or create smart manufacturing processes, what is it that as Intel we think are important tenets? That's what I'm going to go over next. Intel's defined 5 key tenets that define Industry 4.0 IoT platform. So what do these mean? What do they represent, right? These are just principles or guidelines we use to shape our long-term leadership strategy within our company as well as within our partners. They represent what capabilities we want to build in the future in partnership with the ecosystem and everyone else that's helping us build this path to Industry 4.0. So if you look at the tenets, right, they go from the bottom to the top, and security is obviously the key. It should be the fundamental need from the sensor to cloud. We will have to make all our hardware and software assets fully interoperable and secure. So it helps with deploying millions of endpoints, and it makes it easier for our immediate customers and end users to enable a faster path to smart manufacturing. They don't have to worry about the data going into their IT systems or the data they're collecting, and they don't have to worry about any rogue systems if we have the right security. The next key tenet is the critical need to connect, discover, provision, and manage devices at scale. There should be an ability to set up in a few minutes, and there should be an ability to be discovered in a few seconds. So anything more than a few minutes to connect and anything more than a few seconds to discover might not totally change the path, but it's going to just slow down the adoption to Industry 4.0. The next key tenet is the need for data normalization. This is because there's disparate data types before running analytics to change the data to information. Provision for seamless data ingestion. We need to have real-time capabilities and closed-loop control capabilities, and we must be interoperable within a broad set of open protocols. So this is not going to be easy, but eventually, over the long run, we should be able to go and be able to do this in order to have a faster adoption to Industry 4.0. Analytics capability must reside not just at the edge, but in the cloud, as well as any intermediate points based on the application, use case, and need. And these analytics capabilities should be able to provide insight into the value that Industry 4.0 can provide to end users. So what does this really mean? What does providing value to the end user mean? What is analytics bringing to the table? So it's basically creating ways and means to monetize the hardware and software and the data management systems that we are building into the factory floor in our path to Industry 4.0. So the desire to expose the info to developers who can manage and monetize the information to create value and added services is hence our final and the fifth key tenet. So what is it that we want to do, right? So as Intel and thought leaders in this process, we want to be an enabler for the entire ecosystem to be able to extract value from our products and the customers' products, our end customers' OEM products, our partners' products, and derive value from services provided as well. We want to create open, scalable industry standard protocols and architectural designs to make this possible. So that said, this is an intel view of the industry and the market. And now we'd like to go over to see what Mike's going to discuss is being done at Advantech to provide this path to Industry 4.0. Mike?
Thank you, Rama. Excuse me. Yeah, I really appreciate the opportunity to speak with everybody here. My name is Mike Berryman. I am the Director of Product Management at Advantech North America for our automation group. So I want to spend just a few minutes talking about Advantech. And before I get started with that, just so you know, a few of you have found the question and answer button. So if you have any questions throughout this presentation from Rama or from myself, please do click that Q&A and put your questions out there. We'll try to answer some verbally as well as respond to some just typewritten. So just real quick, Advantech at a glance. If you don't know Advantech, we're a manufacturer of automation solutions and industrial embedded computing. We're based in Taipei, Taiwan. We've been in business for over 30 years. We're a global organization of over 7,000 employees. In fact, I'm based out of the Cincinnati office, which is our North American office for automation. Our revenues are about $1.2 billion, and that makes us the largest industrial computer manufacturer globally. Our mission is enabling intelligent planet, and just like Intel enables our products with their technology, Advantech creates products and solutions for machine builders, systems integrators, and users, focused on automation and embedded applications. So very quickly here, we're going to go over the agenda that I'm going to talk about. It's going to be the Advantech Smart Manufacturing Architecture Vision, and we'll spend quite a bit of time on that, and then we'll move into software, importance of software, into these embedded devices to enable IoT and Industry 4.0. A quick case study, and then of course we'll get to the questions and answers. I want to reiterate a little bit what Ron was talking about, the huge opportunities that Internet of Things represents. And I'd like to use this chart to kind of give you a feel for what's happening as far as the volume of the opportunities. For example, you look at the scale of how many notebook PCs are out in the world and how that's been totally overcome by smart devices like a smartphone. And a smartphone is like the new user interface, for example. If you ever have any teenage children, you'll know that they interface to the world through their phones. And that's really the truth for the next generation of everybody, even in manufacturing. Basically, people are going to interact through their mobile devices, and that really is a very interesting concept. So what that happens is, you interface with your phone, you talk to other people through your phone, and text other people, and you do the Facebook and all that stuff. But really, that's the user interface to the rest of the world. So how are you going to interface to the rest of the world? What's going to drive it? There's a thirst for information. And the information thirst for people with the smartphones are driving the kind of the information that's needed to collect data from the real world. And that's going to be the Internet of Things. The things provide us the information to quench the thirst of the users with all the mobile devices. Another way to illustrate this, I call this the bubble chart. So remember the bubble chart because I'll refer back to it a little bit as we go through the presentation. As you look at here, it basically shows the growth of the Internet of Things and what's going on here. The one important thing I would highlight, the yellow box, it represents the connected applications. So that's the software applications that are required to enable all this connectivity and all this great value that comes out of the Internet of Things. And just like, as the iOS, the Apple Store, and the Android Play Store, there's an app for that, right? Everybody says there's an app for that. And what we see from an application standpoint is all these applications will be unique and diverse and not one size fits all. So that's a really important concept that there'll be all these unique applications, unique solutions to problems that we're facing in manufacturing. So if we take the other look at this thing, so we take a look at the number of the bubbles that represent the number of people, like in 2010, 6 billion people on Earth, and 1 billion connected devices. And look how that expands to 2020, which is 50 billion people that Rama mentioned, 50 billion devices and 7 billion people. And then 2040, we see just an explosion of devices, and that's the Internet of Things we're talking about versus the growth in people. So if you look at the ratios, let's just think about the ratios. 2010, for every 6 people, there's 1 connected device, right? So maybe people have cell phones or something like that. Pretty quickly, there's going to be 7 devices in 2020, 7 devices per person. So you think about that. You may think in your household, you may think about how many connected devices you have, and yeah, one person may have up to 7 devices that are connected, and kind of an industrialized nation. But it's not going to be about the user interface side, right? Once you get to 2020, you get so many devices that are connected out there, and not that many users. So what does that mean? So the growth is not really in the user side. It can only grow as fast as the people population grows, right? The growth is on the connectivity to the world. Sensors and actuators and that kind of stuff. And that's what our industry, our manufacturing industry is all about. We've been doing that for decades, as far as connecting devices on the manufacturing floor to do control. So really, the message here is the people that are going to lead in IoT and industrial IoT is the manufacturing sector. And that's pretty much what the next slide shows. Raman mentioned in his data that really, manufacturing and smart factories is going to kind of lead the way in the economic impact from industrial IoT. So that's where, we're going to focus our talk today, the rest of the talk today. We're going to talk about smart factories. And there are obviously there's other impacted industries, and Advantech has coverage in those industries as well, but we're going to stay focused on smart factories for today's talk. So, how is IoT impacting manufacturing? From Advantech, we see 3 kind of trends that are really driving the change in manufacturing. One is 3D printing. As you know, 3D printing has been very popular, and it's really getting a lot of value out of doing fast prototyping and getting new products and solutions to the market. So that's one trend that's really changing what's going on in manufacturing. Another one is robotics, intelligent robotics. So as the robots get smarter and get more autonomous, there's a lot of value that can come out of that. But I really want to focus on what we're calling Industry 4.0 as the focus of what we're going to talk about the rest here. And really the 4.0 represents the 4th revolution in industry. And I wanted to spend a little time talking about that because I'm not sure if the whole audience has heard this. I speak about this a lot. And especially here in North America, there's not too many people that know it that well. So let me talk about Industry 4.0 and get a little background for you. This is a initiative that Germany and Europe has developed, and getting the North American market and other places in the world to understand it has been a little bit of a evangelizing job for myself and a lot of other people. So let's talk about where does 4 come from? Why number 4? So the first industrial revolution, version 1.0, was from water and steam power. So, for example, the first mechanical loom is used as an example in the late 1700s. And so a lot of people call that the mechanical revolution. Revolution 2.0 is from electrical energy, sometimes called the electrical revolution. And the example here is kind of near to my heart because I'm based in Cincinnati, and the example that's used globally for this is the assembly line at the Cincinnati slaughterhouses. And I always get kind of a kick out of this because if you really think about the assembly line in the slaughterhouse, it's not an assembly line. It's really more of a disassembly line. So I always get a joke about talking about that to everybody. The third generation was the digital revolution, right? When you have electronics and computers and PLCs and IT systems, the first programmable automation controller or PLC. So that really helped us automate all these solutions. And then 4.0, and that's what we're going to talk about today, the 4th industrial revolution, we're calling cyber physical. And let me give you an example of what that means. It sounds real Star Trek, right? But what it really means is the interaction of the real and virtual worlds. So, for example, if you would look at a person and take your Facebook page and maybe your medical record your doctor has, maybe your Fitbit data, and you would put it all together, you can probably create a pretty nice model to describe what you are, right? Well, the same thing is happening in the manufacturing space and for machines and the like. There is technology that's happening to gather as much data as you can about the machine and create a cyber version of that machine. So, and as you look at the cyber version of the machine, you can do things like predictive maintenance, see what problem's going to fail. So that's really the kind of technology that's driving the fourth revolution in manufacturing. And so, kind of the holy grail is to change the goal here. The goal here is not just continue doing high efficiency mass production, right? It's not to do that. We do that very well. We can do mass production very well. But it's really kind of switching it to more of what I call ask production, meaning customer asks you to build one thing and you can build it. So it's really kind of getting down to really flexibility in manufacturing, that it's demand-based, or if the customer asks for one, you can produce one and move on to something else. That might be the holy grail, something that we want to achieve. May not be totally achievable, but that's really the direction it's going. Flexible manufacturing, getting out of the mass production and build many of the same thing versus building things that the customers want that are customized to their needs. Okay, so what does that happen? So there's a paradigm shift going on in factory automation to address these kind of demands that you're seeing from customers. If you look on the left side, this is what we call a traditional 5-layer pyramid for automation. You get your field layer, the things that talk to devices. You get your control layer, doing the actual local control. Supervision layer or SCADA layer that's doing the visualization and connecting multiple systems together. And then you have your management layer, your manufacturing layer that's doing the execution systems. And then finally you have your business systems or your ERP or enterprise level systems. The challenge with the pyramid is you have to build the bottom layer to get the next layer, and very rigorous type of architecture. So the issues there, sometimes they're expensive. You've got to have the bottom layers built first, and then and so what even some people do is they're building the bottom layers. You get the field level controller, maybe SCADA, and then you have another group, maybe from IT, that's building the ERP layer. So while you're building a nice pyramid based on square footprint, IT's coming down with something that's more like a cone shape, and guess what? They don't connect. So what we need to do is we need to shift that thinking to something that's a little more freely connected applications, like you see in the cloud-based smart factory, where you have all these applications that are not necessarily dependent on a previous layer being built, and can be flexible and be dynamic. I liken this to like a flock of birds. Each bird itself, of course, is its own little application, but a flock also becomes another type of solution where they all work together and get things accomplished. So this is the kind of things we're advocating for to make things more flexible for that lot one based kind of manufacturing, to get out of the mass production to the ask production. And sometimes we call this the plug and produce concept. Okay, so what is Advantech's vision for Industry 4.0? And this is kind of the three collectives I'll talk about for our vision, and to do the plug and produce concept for smart manufacturing. As we look at this from the bottom up, the bottom layer is intelligent machine and robotics. This is where we use a lot of Intel as a solution partner of Intel. We use a lot of Intel technology in the products that we provide to the market, and a very, very broad array of solutions in that market. The next collective coming up is what we call connected iFactory solutions. So these are the applications that are enabled by the connectivity that's provided by the devices below. And then finally is what we call the Internet of Services. And this really gets into the value of what we see in the applications that can be done. So I'm going to go into each one of these layers individually. So the first layer is the intelligent machine and robotics. So as we take a look at what we're seeing on the factory floor, whether it's processes or machines or robotics, we're seeing a lot of smarts that are having to be implemented down on the factory floor. So anything from, I'll go from sort of right to left here in these bubbles, but sensor measurement. Even Rama mentioned that all the sensors are being put on this machinery to do the predictive maintenance. We're going to see an explosion of sensors. The IoT, that all that data that people are thirsting for, that's all going to come out of some sort of sensors and sensor measurement. In addition to that, there's also from smart controllers, and the controllers are going to be smarter and smarter, whether it's smart robotics or smart machine control. These devices and these machines are really going to get well connected and smart. And the goal is self-organization, right? So when you do this smart, flexible manufacturing, the idea is that machines know about each other and can talk to each other. So and help configure themselves once they know what position they are in the manufacturing space. So the controllers are really important from that perspective. And of course, if you have any kind of manufacturing that requires motion, motion's a very important solution as well. In addition to machine vision. So machine vision is an application that is getting it's growing very quickly in the market. There's a lot of things that can be done with vision, and what's really enabled a vision solutions is the availability of serious processing power that's provided by solution providers like Intel. Processing power that can be embedded into very rugged devices that can go down onto the factory floor, right on the machine, very rugged and robust, and but still provide the horsepower needed to do a lot of image manipulation and processing. And then as we slide on over, we're talking about computing platforms. Computing platforms is the heart of tying all this together with Intel technology, and of course, as well as communication. So one of the key things about the Internet of Things, you get the things and you get the Internet. The things we talk about the things all the time, but the connection of the things is just as important as the things themselves. So the health of your communication networks is very critical in producing an overall system that will meet the next generation of Industry 4.0 applications. Okay, let's go to the second collective that we're talking about. And this one is Connected iFactory Solutions. So from this perspective, you take a look at a smart factory, and Industry 4.0 is really driving the reconfigurable solutions. And to be reconfigurable, there's three attributes that devices need to have. And that's basically all devices got to be instrumented, they're going to need to be intelligent, and interconnected. So as you look at all these devices that are on this assembly line, look like we're making automobiles here, whether it's robotics or drives to drive motors or doing vision, all these devices need to be instrumented, and that means they need to have the latest technology when it comes to sensing the environment around them, being able to read more than just the typical type of the very minimum type sensors to do what you need to do for the control, but also other things like the health of the device itself. So there's a lot of things that need to be done as far as the being instrumented on the factory floor. The next one is interconnected. One of the main things is these devices talking to each other, both directly to each other as peers, and then also back to a host to do the entire coordination. So interconnected is a really key aspect, and you got to have strong networking technology to be able to do that as well. And finally, the last thing is intelligent. So we need to have intelligence, and intelligence doesn't sit just back at the data center, right? We hear a lot of people talking about clouds, and all of the stuff resides in the cloud. Well, yeah, that's great, but you really want to have the intelligence also reside on the factory floor, because you typically, for a manufacturing operation, you're not going to just rely on the cloud to do your closed-loop operations. And so each device also needs to be very intelligent to be able to handle the kind of manufacturing solutions that are being proposed today. So, so how can this be accomplished, right? From Advantech's perspective, we talk about our three layers as well. You talk about being instrumented, kind of on the bottom layer there, all the devices that can be instrumented to talk to the factory floor or whatever kind of production process is in place. Another one is the interconnection. So the next layer is doing the control and the interconnection of these devices together, as well as being able to provide the information up to the intelligent applications. Whether it's a solution-ready package, for things like process optimization, production analysis, and performance, or even just production information. So there's a lot of solutions that are driven by this kind of architecture, and this is what sort of Advantech's view into the type of architecture needed to do the Industry 4.0 and IoT applications. Okay, so let's talk about the third collective here, and this is where we're starting to see a lot of value come out of these solutions, and we're calling it the Internet of Services, but all the services and all the service business and solutions that can be driven with these type of opportunities. So what are the opportunities? So here's an example, and we'll go into one of these in quite a bit of detail. So I just want to give you a feeling for the type of opportunities that are out here for service enablement. One is MES and production profiling. Get information from the end equipment to the MES equipment that's in place. And I think there's more detail coming up later, but I think the one thing I'll leave with you is that even if you have an unautomated factory, there's a lot of MES stuff that can be automated. And it gets back to not needing the 5 layers of automation, but do some more of a concept of just doing the flock of birds concept, just connecting the required applications to themselves. Another one is production testing equipment. We mentioned the machine vision and motion, as well as controllers. Factory environmental monitoring is another big one we're seeing. Part of the production line is not just the production line itself that's making the part, but it's also the facility that is contributing to the health of and the environment of the production line. And then I'd like to talk a little bit more in detail. There was one here about the machine automation predictive maintenance. And I'm going to spend a little more time talking about, a service that's enabled through this kind of application. So let's talk about a little more service, a little more detail. Rama mentioned, he used an example of predictive maintenance. And I'd like to share this slide. And this slide comes from the Center for Intelligence Maintenance Systems out of the University of Cincinnati, and in collaboration with some other universities as well. So this is their content, but I think it really describes very well the kind of things that are going on for Industry 4.0 and to handle the solutions. So if we take a look at this slide, we'll start from the left. We'll talk about the devices that are on the factory floor. And I mentioned, you'll have all these things like, whether it's vibration or force or, you see all the different ones there, rotational speed. The point there is that there'll be more and more sensors put on these devices, and to capture all the aspects of how the device is operating or how the machine is operating. So you're going to see more and more devices being connected. So to do high-end calculations. So what that presents a problem, because you have this huge amount of data. For example, if you're doing vibration data, you're getting a very high data rate, and you're creating this problem called big data. It is a problem because you get a huge amount of data, and it's just data. It's not meaning. So the IMS Center is really addressing the challenges of Industry 4.0 with what they're doing with this big data problem. So you get this big data problem, and what you need to do is to do the smart analytics and to convert that big data into actionable information. And one of the challenges of that is you can stick it out to a cloud and do the big data, but that's pretty much turn offline analysis. So what we advocate is you need to have smart devices that are down on the factory floor that can take this big data, can do the pre-processing of it, do the analytics that are on the factory floor, and come out with the kind of actionable information you need. I'll give you an example of the actionable information. This goes exactly into what Rama was talking about. If you look at the little chart kind of in the middle there, it looks like it runs long at 1, then goes down to 0. That's called a confidence value chart, or basically the health. For example, you might have the vibration and force and all kinds of temperature and pressure you're getting off the machine. But really what people want to know when you're operating a machine is it healthy or is it not healthy? And this is one of the concepts that the IMS Center has come out with. But basically, 1 means you can be confident, 100%. I'm confident that this machine's running well. And basically 0 means it's already down. But in between 1 and 0, you see some indications of things that are happening. And this can help you do predictive solutions to know when the machine will go down, so you can do your fixes ahead of time, or your parts ahead of time, so you don't have the long downtimes, and just do the break fix solutions. So that's a really powerful thing that's being done here. And the way they do this, and I mentioned the cyber physical thing before, it's very similar to that, where there is to process the big data, they have a model that's running that simulates that machine in real time, so using that data, so it can predict where that machine will be based off some histories of other machines. And that's great information. Now that information, I'll have the stuff that, if I look to the right, I'm talking about all these applications that can use this information, whether it's your CRMs or your MES systems or ERPs. You just don't want to jam that big data up into those systems. You want to make sure the information that just that application set needs is produced and then pumped into those production systems. So I would encourage everyone here, I'll give a shout out to the IMS Center. If you want to check out more about the IMS Center, you can visit them at imscenter.net, or just contact me and we can get you in touch with them as well. Okay, so kind of moving on here. That was kind of our architecture vision. I only have a couple slides to do the rest of this here, so I did want to talk about the importance of software. And if you know Advantech, you know us for our hardware. We are a hardware company and always have been a hardware company, but we're doing a major change. IoT is making us change. Both IoT and Industry 4.0 is making us do a major investment in software. So it's really quite important, because if you go back and remember that bubble chart, and that bubble chart had the yellow boxes that talked about the applications. There's going to be 100 million new applications needed to enable the Internet of Things in Industry 4.0. And we know for a fact there's not one size that fits all. It just doesn't happen. For example, the solutions to some of these things will be a mashup between existing applications, small little applications that need to be bundled together like that flock of birds to come up with a solution. Right? I encourage you to check out the If This Then That website, which is basically a mashup of all different kinds of technologies that are out there. For example, if Google weather says that the temperature is going to be so high, make sure I email me that I need to bring my sunglasses or something like that. There's a lot of things that can be done with small little bits of applications or mashups, and that's going to happen also on the factory floor. So what is Advantech doing to address this kind of new architecture when it comes to IoTs and cloud mashups? So here's Advantech's structure, and I will spend just a little bit of time going through this to give you a feel. We can talk about it more. If you have some interest, you can follow up with me later. But if you look at the bottom layer, basically this is the devices, the IoT. These are the things, whether they're embedded systems or they're controllers or I/O devices or wireless sensors. So this is that bubble that has 1 trillion devices. It's going to be these devices and, of course, other devices as well. Right? So there's 1 trillion devices need to have those 100 million applications. So what Advantech has done is create this software package, software solution, platform as a service, PaaS, we call it WISE PaaS. That includes connections to Microsoft Azure. It includes our SUSE access software for device management, the health of your devices. It includes our web access software. It includes SCADA solutions, industrial video solutions, multimedia solutions, as well as network management solutions. So this is basically the application-ready platform that we provide to make IoT-ready applications for smart manufacturing. So if you look under intelligent automation, you see a smart manufacturing there, as well as some other markets that Advantech deals with in both the automation world as well as the world of services. Okay, so finally, let's go through a case study here. So just real quick, there's some case studies I want to talk about. I'll go into one of these in more detail, but from either its overall equipment effectiveness. Again, these are, I think the point here is that these can be individually deployed applications and not need that full architecture, that pyramid, that 5-layer pyramid to do these things. Whether it's overall equipment effectiveness or energy management systems or warehouse management systems and AGVs. There's a lot of solutions we've done. And I'd like to spend just a few minutes talking about one in detail. where this is a manufacturing execution system, or MES system. This use case here is a food and beverage application or a factory, and they didn't have a lot of automation really in place to do it, but they still wanted to put an MES system in place. So there's a lot of solutions you can put out there to get the information needed to run an MES effectively with real-time data, whether it's tank monitoring or it's equipment integration or the weigh scales, or even integrating the operator rounds with tablet, mobile tablets, industrial mobile tablets. So these are the kind of applications that we see happening all over the place, using Internet of Things technologies to achieve Industry 4.0. Okay, this slide is sort of the kind of recap the discussion I just went through. We talked about the three, the three different collectives, whether it's intelligent machinery and robotics, it's connected iFactory solutions, or the Internet of Services. This is kind of the architecture Advantech is promoting in the market. Again, if you have any feedback, you let me know. And I think, Rama, if you're there, I think we've reached our Q&A time here.
Yeah,
so
yeah.
Let's. I wonder if there's any Q&As in here we can.
So I have one question from Brian Watkins.
Mm-hmm.
Sorry. So can you contrast your software stack to Intel Moon Island stack? So this is based off of the software stack we were sharing a few slides ago.
I think we probably need to get more specific, and I'll admit that I don't know Intel's Moon Island stack, to be honest with you. Maybe you do, Rama. But I think from a software perspective, one of the things that we're trying to be as open as possible. So what we're doing is we're doing things. We're doing like a RESTful interface in JSON format, as well as some other things to connect to other third-party devices. So I'm not sure, but we get the details of the protocol stacks, and I don't know if you can speak to that, Ram, as far as Moon Island goes. But I think we can take a look at that and get back to you also.
Sounds good. So the next question: looking at some of the industry-leading lean manufacturing organizations, what is their adoption rate of Industry 4.0?
That's a great question. And again, Industry 4.0 is a revolution, and I think you're going to see, at least in my experience, and I think you can look at different areas of the world differently. I think the first solutions, the real solutions, adoptions of Industry 4.0, you'll see in Germany, just because there's a big force behind it, including both industry, government, and academia. So I think you'll see it happen there as well. The other lean manufacturing organizations, I think they may take a look at it and pick out the ideas, the concepts. I think that's part of what we're doing here is we're talking about the concepts and expand upon the concepts that are being produced.
Thank you, Mike. The next question I have is, how do you compare Advantech IoT platform to ThingWorx?
Okay, so what I would say, ThingWorx is a great Internet of Things solution that's out there, and I would say from a Advantech standpoint, we would work with ThingWorx, right? We are providing basically an application-ready type connectivity package, so it's not. Advantech has a solution and ThingWorx has a solution. I think Advantech is working to make sure that Advantech devices and solutions can be, say, cloud ready. And that may be a ThingWorx solution, and maybe something that's built just purely on Microsoft Azure. So I wouldn't say that there's one or the other. I would say they are meant to work collaboratively.
Thank you, Mike. So I think this is more of a generic question, but what software would you recommend to use for factory floor analytics?
Wow. I think that's a general question, Rama, just like you said.
Yeah.
And I think we need to be more specific. And
To
I'll
the
tell you one
application
thing.
and the use case.
Yeah, very application specific. And one thing I think I'd highlight, just based on my experience with working with the Center for Intelligent Maintenance, IMS Center, it really comes down to there's not necessarily one software that's not one size fits all. And you really got to look at whether it's a specific machine and analyze that machine or device and come up with a solution. So, I hate to say that, hey, use this software from Advantech or from somebody. I don't think that's the answer. I think the answer is 100 million different answers, just like we saw on the slide.
Okay, cool. I think we can go through a few more questions. We are almost at the top of the hour here, but
Okay.
I have one or two more here. How does Industry 4.0 affect OEE?
So that's an interesting question. So, the whole idea about Industry 4.0 is reconfiguration and reusability. OEE, you're trying to figure out what percentage of that usefulness is that machine really producing. So, and there is some reconfiguration time that goes on it. So there's a discussion I know going on in the industry about during the reconfiguration time, do you really consider that as part of the downtime for OEE or not? But so that's a great discussion.
Okay, this one's probably a simpler question. What percentage of your business is this currently? Assuming this is a question.
Well, I guess that's a pretty general question. The Industry 4.0 is a new direction. It's going to require smart devices, and from Advantech perspective and Intel's perspective, we make technologies that make things smart, right? So you could say that, hey, maybe we're selling, there's an industrial computer that's going on the factory floor that has Intel content, Advantech content. Can you say that's being used for Industry 4.0? No, but could it in the future be used for 4.0? Yeah. So, I don't think I can say a percentage of business, but I can tell you that what the consumers are asking for us is smaller, faster, smarter devices that is going to increase the value of the applications they can deploy.
All right, cool. Thanks, Mark. We are 2 minutes before the end of the hour here. We do have a few more questions, but I think we should take them offline to be able to close this call on time.
Okay.
Thank you, guys.
Yeah. For Mike Berryman here, I just want to thank you. I've got my contact information there if you want to give me a call or email me to follow up with any information. I really appreciate the time from both Intel and everybody on the line has provided for us. And Rama, do you want to say some last words?
Sure. Yeah. Thank you, Mike, and thanks everyone on the call. Please do keep sending us any more questions you have, and we'll take them offline and reach out to you. Thank you.